Hello, and welcome to the National Weather Service online video tour. I'm Charlie Woodrum, and I'm one of the meteorologists here at the Weather Forecast Office in Pittsburgh. The Forecast Office in Pittsburgh is one of 122 across the country, and we service western Pennsylvania, eastern Ohio, northern West Virginia, and one county in western Maryland.
The layout of the Pittsburgh office is a unique one. Most offices are a typical cookie cutter shape and one level, whereas the Weather Forecast Office in Pittsburgh is a multi-level building with the management and electronic technicians' offices for the most part on the top floor and operations on the bottom floor.
While in operations, maintaining situational awareness is very important. And so we have a situational awareness display where we monitor guidance from the national centers, regional weather, and also our local and national television coverage. This is what a workstation looks like for our meteorologists here at the Weather Service. And we use a weather monitoring program called the Advanced Weather Interactive Processing System, or AWIPS for short. And with AWIPS, we can look at model data and see the latest runs. We can monitor the radar, which we use to issue warnings through a program called WarnGen. We can also look at satellite imagery and also issue our forecasts and our watches, warnings, and advisories through a program called the Graphical Forecast Editor, or GFE for short. We also use two screens for our personal computer where we can access the internet and get to our email and other information. Forecasters use a program called the Graphical Forecast Editor, or GFE, to draw their forecast so it can be easily communicated to the public. And they use GFE to make decisions with things like, what's the high temperature going to be today? What's the chance of precipitation? How strong are the winds going to be? And they can edit each weather element using this program and quickly produce a forecast. To edit a forecast grid, it just takes a few simple clicks for a forecaster to make changes to the forecast. And they can easily adjust the temperature, for example, up or down, or highlight an area that they want to adjust. These can all be done quickly with just a few clicks of the mouse. Forecasters can utilize the Graphical Forecast Editor to issue long-fused watches, warnings, and advisories. Everything from a winter storm warning to a heat advisory. To do that, they can go to Make Hazard, select the counties that they want to issue the hazard for, select the hazard type, then select the start time and end time for the hazard, and then run the hazard. To issue warnings, we use a program called WarnGen, and you click on the yellow box in the upper right hand corner to load WarnGen out of AWIPS, and then this polygon pops up from the point. You track your storm motion, and then it draws a polygon for you. Then you select what kind of warning you want to issue, in this case a severe thunderstorm warning. You say your basis for your warning, the threats involved, in this case we'll use golf ball size hail, and calls to action that you might want to add. Then, once you have the polygon in the correct shape that you want, then you just click the Create Text button and it creates all of the information in the warning automatically based off the polygon that you drew. WarnGen then produces the text product for the warning that you want it to issue. And it mentions the time the warning was issued, the area it was issued for, how long it was issued until, the hazards involved with the thunderstorm, and the locations that will be impacted.
This is the Pittsburgh WSR-88D, stands for Weather Surveillance Radar. It was commissioned in 1988, and it's a Doppler radar. Doppler radar ends up working by detecting a pulse or some type of precipitation as it comes towards the radar, and the frequency ends up changing as it hits the particle. The Pittsburgh radar was a beta site for getting dual pole installed. It was one of the first half dozen radars in the country to get this. instead of a pulse hitting a particle and measuring one dimension of the particle, now anything that the radar hits is sampled in two directions, in two dimensions, so that we can actually end up getting a horizontal and a vertical size.
Hi, I am Art Brown. I am the Electronic Systems Analyst for the Weather Forecast Office here at Pittsburgh. We are responsible for all of the equipment. That includes the AWIPS computers, that includes all of the networks. We have 3 different networks. We're responsible for all the networks, all of the email, everything coming and going into this office. We have 7 ASOS sites in our county warning area that we're responsible for maintenance on, software upgrade, all of the maintenance. And we have the Next Red radar. We're responsible for all of the modifications, all of the upkeep, all of the maintenance on that system.
Hi, my name is Fred McMullen. I'm the Warning Coordination Meteorologist here at the National Weather Service in Pittsburgh. And I'm going to talk to you a little bit about the Storm Ready program that the National Weather Service does. This program is where we partner with counties, townships, special event venues, universities through advanced planning, research, education, and awareness. These communities become what we call storm ready. What that means is that through all that information, they have the infrastructure in place so that if they can withstand the onslaught of severe weather. Skywarn program is a program that's consisted of volunteers nationwide of approximately 300,000 people. Locally, in the parts of eastern Ohio, western Pennsylvania, western Maryland, and northern West Virginia, we have about 4,000 volunteers who are our eyes and our ears for storms as they come across the area. The Skywarn program is usually rolled out in the springtime, where we go out to the counties and give presentations about what we're looking for to become a storm spotter, what to observe, how to report hail, wind damage, how to observe flooding. But we also give safety tips as well, because weather can be a hazard if you don't know the proper steps to take. Our office has a unique capability where we can go out to schools, universities, counties, civic groups, Kiwanis clubs, and talk about the weather. We service all types of demographics, young children to senior citizens. We talk about what's current with the weather, maybe a severe weather history across parts of the area. We do preparedness talks so people in hospitals know what to do if a tornado warning is issued or a severe thunderstorm warning is issued. And we also do demonstrations out at PNC Park for Pittsburgh Pirates Weather Day. So we have a various program that we go out into the community and train folks on the safety measures to take when they're outside and the storm happens, what to do.
Hi, I'm Bob Reed. I'm one of the forecasters here at the National Weather Service Forecast Office in Pittsburgh. And one of the things we do here is aviation forecasting. We issue aviation forecasts for 24-hour periods for 9 different airports across eastern Ohio, northern West Virginia, and western Pennsylvania. One of the airports we forecast for is the Pittsburgh International Airport.
The harmless weather instrument that collects valuable data from the atmosphere is called the radiosonde. The humidity sensor is located in the front of the sonde, while the battery component is located in the back of the sonde. There are even mailing instructions to mail the instrument back to the National Weather Service if found, and the temperature sensor is located at the top. There are 70 offices across the continental United States that launch weather balloons at the same time. Our office launches weather balloons once in the early morning and once in the evening. As soon as the radiosonde is released, it gets tracked instantly using GPS until the flight is terminated.
To visit our webpage, go to weather.gov/Pittsburgh. From there you can access our point-and-click forecast, where you can find weather information for your local area.